The Shainin methodology, also known as the Red X model of systems variation, is a technical problem-solving approach developed by Dorian Shainin for solving complex technical problems. The core premise of the Shainin method, or Red X, is that in any problem, there is a dominant cause of variation in the process output that defines the problem. Shainin terms the dominant cause the Red X. There may also be a second or third cause. Shainin calls these the pink X and pale pink X, respectively, that make a substantial contribution to the overall variation and must be dealt with in order to solve the problem. The Shainin approach follows three principles for solving problems. There is always a Red X. The fastest route to identifying the Red X is a progressive search using a process of elimination. Talk to the parts with tools that are both rigorous and statistically simple. Shainin problem-solving projects utilize a discovery approach to uncover the critical relationships through a process of elimination. This means looking at the effects of the problem and asking, what is the difference between an extremely good and extremely bad product, using Shainin terminology, best of the best, BOB, and worst of the worst, WOW. Rather than ask subject matter experts to list possible causes, the Shainin method uses insights to develop a strategy to talk to the parts, to reveal their differences. The Shainin problem-solving roadmap or process is factual: focus, approach, converge, test, understand, apply, leverage. Shainin can be used for both deviation problems and variation problems. Shainin breaks a manufacturing process down into its most important inputs. It follows the idea that a change in the most important inputs creates a big change in the outputs. Using this information, you can identify which inputs need to change to provide a different output. A simple example is of a car manufacturer who produces two different types of cars. An issue appeared in which the seats would rattle, typically more in the first type of car than the second. When the seats were transferred from the first type of car to the second, they would still rattle. Using the Shainin method, the manufacturer was able to identify which parameters in the seats rattled in the first type of car, but not the second. Shainin is appropriate to use when the problem is large and very complicated, and root cause is not obvious after first trying simpler problem-solving methods, including fishbone, 8D, and so on. If you're familiar with KT problem analysis, Shainin's BOBs and WOWs can be likened to KT's is and is nots. Those familiar with Six Sigma will see the links to statistical methods.